Hi dear students, this is the sixth video about the area perimeter and volume, and we are going to continue with the compound areas. And as you see from the definition, compound shape is a shape that made of two or more shapes put together. So in the examples, as you see, the triangle and the rectangle comes together. This becomes one compound shape, and semicircle and trapezium comes together, and this is compound shape. This is right trapezium and rectangle comes together when we put them together, and we are going to get one compound shape again. For finding the compound shapes, here the names of the figures that I set, we are going to calculate the one by one them, and we are going to get their areas with respect to that one, which means I'm going to find the trapezium area and rectangle area separately, and I'm going to add at the end of the operation. Here we have in the exercise we have trapezium and rectangle. Now for finding the area of the compound shape here, first I'm going to calculate the area of the trapezium here, and like this figure it is, and for the rectangles area. But for this one also I need the lengths of them. Here we should find generally for this kind of questions correct lengths for the area of the small figures here. Small figure I mean trapezium and rectangle. Here if the distance of the one side of the rectangle is 5, this is going to be also 5. If I name this side as A, then A plus 5, it's going to be A plus 5, it's going to be equal to 11 centimeter, and A is going to be equal to, when you send to the other side, it's 11 minus 5, it's going to be, A is going to be equal to 6, you know this one. So here the A value is equal to 6, and the length of the, for the trapezium's area, you need for the area of trapezium, I'm going to write A plus C divided by 2 times H, it's going to be times H divided by 2, it's going to be, and we need the perpendicular height. Perpendicular height, this length this is the perpendicular height, H, it's going to be, and the length here 4, and here also it's 4, so H is equal to 8, it's going to be. With respect to that one, the area of the trapezoid is A is equal to 6, C is equal to 4, 6 plus 4 times H is equal to 8 we found, divided by 2, it's going to be, which is equal to 10 times 8 divided by 2. If you simplify, this is going to be 4 and this is going to be 1, and here it's going to be 4 times 10 divided by 1, which is equal to 40. This is the area of trapezoid, 40 centimeters square. What about the second area of rectangle? Area of rectangle is going to be A times B, which is equal to A length, it's A, do not confuse with this A, base times height, we can say also base times height, I'm going to say H, and base is equal to 5, the height is 4, so 5 times 4, it's equal to 20 centimeter square, it's going to be. So area of the compound shape, CS, I'm going to say, area of the compound shape, it's going to be equal to 40 plus 20, which is equal to 60 centimeters square, going to be. Okay, the surface area using the nets of solids we have also in this topic, and we are going to find the surface area of this triangular prism, and we have to open that one. Only the important part, you should try to understand how to open this figure. Firstly, it's going to be here. I have one rectangle here, I have one rectangular base here, and one rectangle over here, which is not obvious here, cannot be seen from this side, from this looking view, I mean, and you cannot see from this side. This is the first one, this is the second one, and this is the third one. It's going to be okay. So with respect to that one, let's draw the figure. Here I have one big rectangle. I'm sorry, let me use the rectangular shape here. I have one big rectangle, and this rectangle's here, the length, it's going to be the 10 centimeter and the 15 centimeter. This is 10 centimeter and this is 15 centimeter. It's going to be, which is connected to this one, we have 1, 8 and 15, and which is connected to this one, again we have 6 and 15. All they are connected to each other. The figure, it is not seem like that, but here I'm going to make them closer to each other, or like this, like there is one line. It should be like that. Normally we should see only one line here. Yes, the figure is more better like this here. Yeah, this is the correct figure now. And I'm going to, one second, sorry, and I'm going to draw the triangles on the cross-sectional part here, this part and this triangle we have. So I'm going to use lines for that one, but this time the lines I'm going to choose not very unique here. It's going to be something like this, maybe here. This one, it should be like this. Actually the figure, it's the length here, it's maybe it should be, this is longer than the other one. It should be, why? Because when we fold this length, I said it is 8, so this length and this length, they are going to come together. I mean this one and this one, it should be together. I mean here I'm talking about this one, this length and this length, it should be same. Okay, here this one I couldn't place correctly. Yes, here it is, and one length. And I'm going to do the same figure on the other side here. This one, this length here, I'm going to copy again. I'm going to use that one, that model, I mean. Okay, that's the figure. It should look like this. At least it should look like this. Okay, the area of the things we are going to find, but before then, that one, I open the figure and I'm going to now write the lengths here. This is 15 centimeter, which is this distance. The next distance here, for 15 and 10, it's coming, so this is the 10, the length it is, and this is here, this is going to be 8 and this is going to be 6. And here the important part here, the triangle is this triangle also, and this triangle, they are same. I forgot to tell that one. This is also 10. The triangle is right triangle. It's going to be triangle. Why it is? Because 6, 8, 10 is special right triangle. So this is right triangle, and it is easy for me to find the area of the triangle. In the right triangle, I know that this is the right corner. With respect to that one, the area of the triangle, it's going to be here 6 times 8 over 2. Area of the triangle, it's going to be, which is equal to here, that's going to be equal to 24. Let me here this one 4 and this is 1, that's equal to 24. Yes, it's true. So the area of the triangle, it's going to be 24. This is also 24. It's going to be, Then this length is 15 for all of them, but this length is, it's going to be 8. So this is 15 times 8. This is 15 times 10. And this is 15 times 6 it's going to be. Also, you can do like this, since it is all there 15 times something. This is 6 it's going to be. Sorry, 15 times something. Here this length you may calculate totally, then you can multiply, but here this is another method. 150, this is 120 it's going to be, and this is going to be 90. So when you add them side by side, this is 240, pardon, 150 plus 90, it is 240, plus 120, it's 360 it's going to be. So total area 150 plus 120 plus 90 plus 24, and 24 it's going to be here. So which is equal to total surface area of this solid. It's going to be 24 plus 24, 48. I'm sorry, this is 360, this is 48, and the result it's going to be 408 centimeter square.